students, in this video I'm going to do a demo regarding electrolytes. So what I have here is a light bulb, but you see I have these two prongs on the bottom. They are not connected. Even though my light bulb is plugged in, it is not on. That's because our circuit essentially is incomplete here. So what I'm going to do is I'm going to put this into a number of different solutions so we can figure out which ones are electrolytes, meaning they are able to conduct electricity, and which ones are non-electrolytes, meaning they cannot conduct electricity. So I'm going to start first with our deionized water. Now, deionized water is pure H2O, so we would not expect that to have any ions available to conduct electricity. So let's test that out. As you see, very anticlimactic, nothing happens. Now, what about if I use tap water? So tap water does have some additives like fluorine and things for your teeth, so let's see if anything in there can conduct electricity. Now you see the light bulb does light up a little bit, but it's pretty faint. That's because there are some things available in here to conduct electricity, but really not too many, so it's more filled with weak electrolytes. Okay. Now I'm gonna use my deionized water for now just as a rinser, to make sure I'm not contaminating my solutions. Now next up I have acetic acid, and acetic acid is a weak acid, which we'll talk more about later, but weak acids are also weak electrolytes. What happens is the acid molecules, some of them separate into hydrogens and the anion, but others stay together and are molecular and do not conduct electricity and do not separate, so therefore they cannot conduct electricity. But if this is a weak electrolyte, we would expect our light bulb to light up, but a little bit brighter than our tap water, but still not full blaze, okay? So weak acids, like acetic acid, which is what is in vinegar, are weak electrolytes, same deal with weak bases. Okay, now let's test salt. Salt is an ionic compound, which means it will fully dissociate into a metal and non-metal, and we would expect this to be a strong electrolyte. Okay, so I took my salt and I dissolved that in water to give me a salt solution. You can still see some of it in the bottom of the beaker maybe. But when I dissolve that, remember, I'm expecting all of those ions to fully dissociate. I would expect a salt water solution to be filled with strong electrolytes. And notice, my light bulb is very, very bright, right? I don't want to look directly at it. I already made that mistake once. So, much, much brighter than our weak electrolyte vinegar. Remember, as a comparison, here's the vinegar, a weak electrolyte. Here is salt, our strong electrolyte, because it's fully ionic and that whole solution is filled with ions. Now remember, salt can only conduct electricity when dissolved, because that's when the dissociation happens. Now my final beaker I have here for the moment is sugar. Sugar is molecular, it's made up of all nonmetals, so I would expect this not to dissociate into ions, meaning I would expect this to not be an electrolyte, or in other words, it will be a non-electrolyte. So we see nothing too terribly exciting happening here. Our sugar solution, sugar dissolved in water, is not producing any sort of electric current there. Now I have one final one just to round us out here. So what I'm going to do is I'm going to dump my DI water beaker and I'm going to exchange that for a sports drink. Now, any sports drink, especially Gatorade, but any sports drink always has on the label that they're filled with electrolytes so that you can get back to playing your sport as fast as possible, right? So let's see if that claim is really true. So I've got my sports drink here. If this really is filled with electrolytes, think about what we would expect to see with our light bulb. Here we go. Notice we see a very bright but a very bright light bulb here. That means that there must be a lot of electrolytes in this solution to conduct electricity, and that is exactly what we see. So there must be all sorts of different ionic compounds in sports drinks in order to allow electricity to flow and also to get you back playing your game faster. So I hope you found this little demonstration helpful.